Hello everybody, I'm Ivan. Today I'll be starting another project for upgrading the CR10. It will be maybe an ultimate upgrade before I start another project for building a Voron Core XI printer, which is quite ambitious for me. It will be maybe a project for several months. But okay, first I decided to give the best to take out the maximum of this printer by implementing linear rails both on the Z-axis and the Y-axis. I have already a linear rail on the X-axis, but I will try also to implement the second parallel linear rail on the X-axis in order to be able to attach heavier print heads. So my little man cave is full of stuff. It took a lot of time for some things to come, but finally I think I have everything. Parts, printed parts. I hope this project will take maybe 2 weekends. And first I'll be starting with the Y-axis this weekend. So here you see the current solution from Creality. The hot bed is moving on V-wheels. Those were for a couple of months of daily use. You can see some black particles from the plastic. This leads to play of the bed, and when tightening doesn't help anymore, you will have to change the V-wheels. Instead, I'll be using 2 linear rails that should improve both the stability and the precision. I will also change the 6mm GT2 belt with a 9mm one. Finally, I printed a tensioner for the new belt from polycarbonate. Check the description for the parts I use. For this modification, the heated bed and the 2040 extrusion in the middle have to be disassembled. I bought the linear rails from Robotdick. Those are NGN12 stainless steel and high quality Chinese rails, good alternative of high wind. They are 500mm long. For the Y-axis, each of the 2 rails has 2 carriages. The linear rails will be attached to 460mm long 2020 extrusion. I'll be using a combination of standard T-nuts and spring-ball T-nut. The spring-ball T-nuts help to suppress vibrations, if any. In order to attach the carriages to the hotbed supporting plate, I printed a drilling template and marked the holes. I used the same template for the both sides of the plate. The supporting plate is from 6 mm thick aluminum. It will be attached to the carriage with M3 bolts. I used first a 1 mm drill bit and then a 4 mm one for the final holes. This gives some tolerance because my drilling technique is not the most precise one. I also printed 7 mm toe spacers. Those will be between the linear rail carriages and the supporting plate and are needed to create space for the timing belt. Once everything mounted, it was relatively easy to adjust the parallelism of the two rails, and the supporting carriage is moving smooth. Here you can see how I attached the 9 mm belt using thin strips of metal sheet. Modifying the Z and the X-axis requires to disassemble the top 2020 extrusion and the gantry. The Z rails are also 500 mm long MGN12. There are several existing solutions for mounting linear rails for the Z-axis, and you can check them on Thingiverse. They require to change the position of the X-axis stepper. I wanted to keep the stepper where it is, because I think this position provides good balance. After short study, I decided to position the Z rails on the right side of the 2020 extrusions. The mounting elements for the right side of the gantry are available on Thingiverse. For the stepper side, I had to design my own solution. For the X-axis, I used two rails, MGN12 mounted on the front side and MGN9 mounted on the bottom of the gantry. The print head is a modified version of the tank print head I presented in another video. I had really tough time to align the Z rails. It was much more difficult than the X and the Y rails because the distance between the rails is big and very small deviations lead to difficult movement. The technique I use for aligning the rails is to fix the first rail and then to progressively tighten the screws of the second one while moving the carriage. Well, this didn't work for the Z-Rails. It took me some time to realize that I should first synchronize the two sides of the gantry before making the alignment, because when testing by hand, there is always more force applied on the right or on the left side, which leads to deviations. When I synchronized the gantry, aligning the rails was easy, and now they move very smoothly. The belt on the x-axis should also be modified. Because of the MGN 9 rail mounted on bottom, it can no longer go inside the 2020 extrusion. On the left side of the gantry, I used one of the holes of the stepper and a headless bolt to attach an M3 idler. On the external side, the bolt is screwed to the stock M3 spacer. The front plate for the X end stop was also modified to host the spacer. On the right side of the gantry, I modified an extensioner from Thingiverse to hold another M3 idler. Here you see the X belt in action. I printed few parts to test the print quality. First, I printed a benchy and a calibration cube from PLA at 0.2 layer height. The calibration cube printed perfect. The benchy had some layer artifacts on the cabin, but those are due to stringing, which is related to the printing profile and not to the mechanics. So I consider it a success. Then I printed a measuring cube and an ocarina from ABS. The measuring cube was printed at 0.35 mm layer height and with very cheap ABS filament. The quality is okay for this resolution. The ocarina printed at 0.25 mm layer height, 100% in fill, from Amazon Basics ABS. The print quality was perfect. So, in conclusion, I can say that this upgrade improved the quality a bit, and I'm happy with it. What's good as well is that the system is so rigid that I no longer need this type of auto bed leveling sensors. So the BL Touch goes to my stock of spare parts. I have also implemented these supports for the Z-axis, and you can find the links and the modified elements in the comments below. This helps to make the printer sturdier for taller prints. I had to design a part for the Y-axis end stop. It holds also the back of the Y-axis stepper. Please check the description for more information on the parts I used. So thanks for watching and see you soon for another project.